Okay, see Lindelof videos, graphing exponential growth functions. I wrote a little note here about what exponential functions are and some definitions. I will just remind you that to be an exponential function, f of x will be equal to a times b. The variable is where the exponent is, and that's how you recognize it as an exponential function, plus k. I could go through all of this, but I'm not going to. What I am going to tell you is this, that reading the equation correctly is the absolute key. I know that your teachers or professors have given you these kind of algorithms or models for step one is this, step two is the other thing, etc. However, the mistake I see very often is mistakes like this. So today we're going to be looking at these two functions, and they're on the next page, and we're going to see them. But the first one is f of x is equal to 3 to the x minus 2. The second function, now tell me if this doesn't look similar, but it's vastly different. F of x is equal to 3 to the x minus 2. So I have a lot of students come to me and they're like, Lindelof, how are these different? Or how come when I graphed this one, it came out, my professor said I was wrong, well, possibly because this great student thought that 3 to the x minus 2 was the same as 3 to the power of x minus 2, is that these two are the same functions, and they're not. So let's just graph them really quickly. This one that we look at here, we know that the a value is 1, the b value is 3, and then we have a k value here, and the k value is negative 2. The k value tells us vertical shift, right? It raises and lowers the graph. As if you pulled the graph away from the plane and just picked it up. You didn't bend it, you didn't do anything, you just picked it up and you just lowered it by, in this case, negative 2 steps down. So that's what that looks like. So let's go ahead and graph this one really quickly. The first thing I always do before I even set up my thing, I ask myself a question. What's the value of b? B is, in this case, 3. 3 is greater than 1. So I know that the general shape I'm going to get is going to look like this. I'm not going to put it on the Cartesian plane, but it's going to look like this. Professors look for that. Sometimes they're not paying as close of attention as you think to other things. But if you make this general shape wrong, then he or she is definitely not going for it. So let's do this. So we know this. We got this checked off. Second thing I'm going to do is I'm going to ask myself, what is f of 0? So f of 0 in this case is 3 to the 0 minus 2, right? Please remember, any number to the 0 power, with the exception of 0, is equal to 1. So 3 to the 0 power is 1. And 1 minus, wow, did you see that? 1 minus 2, right? 1 minus 2 is equal to negative 1. So 1 minus 2 is equal to negative 1. So that gives us this, right? That gives us a point, and that gives us the point 0, negative 1. Now I'm going to go ahead and create my Cartesian plane, and I'm going to put that point in. 0, 0, negative 1, isn't it? Remember, I know that it's going to have this shape, so I could actually just pick this up and put it down here, but I'm not going to do that just yet. I'm going to graph one more point, and the point I'm going to graph is let's do f of 1, g of 1. So g of 1 is equal to, right? G of 1 is 3 to the first power minus 2. 3 to the first power is 3. 2 is 1. So we have the point 1, 1, 1 maybe, right? 1, 1, 1, 1. So then I'm just going to take this curve and put it here. Remember, though, that this function is, I'm going to leave it like this, but this thing is asymptotic to the y-axis, and the bend is definitely not like this. The bend is actually more gentle, like this. So forgive that. But this is what this graph should look like, right? It's the right shape. It has a horizontal asymptote as y equals negative 2. So we're going to put this as y equals negative 2. So I'm saying this thing runs close to that line. Okay? All right, let's take a look at the next one and see how it's actually different. So this time, this negative 2 is not. It's not the k value. It's part of the argument. So I know, again, that the b value is 3, so I know that I'm going to get this general shape, right? I'm going to get that general shape right there. And I'm going to do exactly what we did before. And let's actually see what happens with this. It comes out looking a little bit different. So you can try this. I'm going to let's take f of 0. Say f of 0. And we put that in. We took f of 0 last time. We got a vastly different number than we're going to get here. So we get 3 to the 0 minus 2 power. 3 to the 0 minus 2 power is 3 to the negative 2. Word of caution. Please remember that negative exponents create reciprocals, fractions, however you want to describe that. They do not create negative numbers, right? Negative numbers are created in front of the number. They're not, negative numbers are not created in the exponent. So don't think of it as a negative number. Instead, what this really is 1 over 3 squared, right? So, right, it was like this. It was like this, and I just took the reciprocal, I flip it over, and I got is equal to 1/9. So I have the 0.01/9, which is going to be a pain in the neck to actually graph, but see, it looks like this. So we have 0, let's just put that point there just for crap's sake, right? And then I'm going to just graph at least one more point. I think what I'm going to do is graph f of 3, and you'll see why in a second. F of 3, check this out. So I'm asking what happens to my graph when x is 3, and I get 3 to the 3 minus 2. 3 minus 2 is 1. I get 3 to the first power, which is equal to, of course, just 3. So we get the point 3, 3, right? So this is the point 3, 3. This is the point here, 0, 1, 9. And this graph looks like this, right? Just like it does over there. It gets to here, and it starts to bend up like this. All right? So remember, here we have a number up here in the argument, right? So this is what I see here. Even if, and this just really sucks, you guys, and I want to say it, sometimes you'll have a professor, or even in a book, you'll see it written like this. And when you see that, you really have to stop yourself and say, okay, all this crap is up at the top. All of this is in the exponent, and then act accordingly. All right? So I hope this is helpful. These are the most common mistakes that I see when people try to graph exponential functions. And the mistakes they make are they don't read the equation carefully. You can do that. Thanks for watching. Any questions or comments, please let me know. And if you haven't already subscribed, please do.